Hi, now we are going to talk the problems related with current electricity, part 2. We are going to discuss resistors connected in series and parallel, problems related with resistors connected in series and parallel, temperature coefficient of resistance, internal resistance of a cell, Kirchhoff's laws, current law and voltage law, basic concepts, problems related with the current electricity. First problem. The storage battery of a car has an EMF of 12 volts. If the internal resistance of the battery is zero point 0.4 ohms, what is the maximum current that can be drawn from the battery? EMF is given, internal resistance is given. I max, maximum current. EMF, voltage by resistance, we call it as current. So it is EMF by internal resistance. The value of EMF is 12 volts. Internal resistance is 0.4 ohms. 12 by 0.4. 120 by 4. 30 ampere. Straight problem. Second one. A battery of EMF 10 volts, internal resistance 3 ohms is connected to a resistor. If the current is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery? EMF is given, internal resistance given, current is given, 10 volts, 3 ohms, current is 0.5 ampere. Formula I is equal to psi by R plus R. So R plus R is equal to psi by I. That is 10 by 0.5. 100 by 5, 20 ohms. R plus R is 20 ohms. So capital R is asked 20 minus small r. 20 minus 3. So R will be 17 ohms. 17 ohms. Terminal voltage means across the voltmeter, what is the voltage you are measuring? Definitely it is less than the EMF value. EMF and potential difference. Main difference is maximum value of potential difference is EMF. It can show maximum value or less than that. Because of internal resistance is there means always V is less than psi. Psi is called the maximum EMF. Therefore, terminal voltage V is equal to, what is the formula here? Basic formula Ohm's law, that's all, IR. R we have calculated. Current is 0.5 into 17. 8.5 volts. See, total EMF is 10 volts. Because of 3 ohms internal resistance, we are getting the answer only 8.5 volts. Okay, fine. Third problem. Three resistors, 1 ohm, 2 ohm, and 3 ohm, are combined in series. What is the total resistance? If the combination is connected to a battery of EMF 12 volts and negligible internal resistance, Obtain the potential drop across each resistor. Connected in series means resistors in series formula Rs is equal to R1 plus R2 plus R3. Basic formula. The value 1, 2 and 3. 1 plus 2 plus 3. 6 ohms. It is 6 ohms here. Therefore, current I is equal to V by Rs. What is the potential given? EMF of the battery is 12 volts. 12 by 6. So 2 ampere current. What is the potential drop across each resistor is the question. Therefore, V1 IR1, V2 IR2, V3 IR3. Here you should know current is constant in the case of series resistor. Current is constant. In parallel connection of resistors, potential difference is constant. In series connection of resistor, current is constant. So V1 is equal to 2 into R1 is 1 ohm. So 2 volt. V2, 2 into 2, 4 volt. V3, 2 into 3, 6 volt. When you say total value is 12 volts, that means question is V3 IR3. Question is negligible internal resistance. If you add V1, V2, V3, you are getting 12 volts. That is what your EMF. EMF and potential difference or potential both are equal means internal resistance is negligible or zero. Theory. Okay. Fourth problem. Three resistors 2, 4 and 5 ohms are combined in parallel. What is the total resistance of the combination? If the combination connected to a battery of EMF 20 volts, negligible internal resistance, determine the current and the total current. Previous problem, resistors connected in series. This problem, resistors connected in parallel. So 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Value 2, 4 and 5. 1 by 2 plus 1 by 4 plus 1 by 5. 20 is the LCM. 10 plus 5 plus 4. 19 by 20. So Rp is equal to 20 by 19 ohms. Implies current I is equal to psi by Rp. What is psi value given? EMF 20 volts. 20 by Rp is 20 by 19 numerator. So 19 ampere current. In parallel connection, potential is same. Current is different. Water flow, it is equivalent to water flow. Second floor, first floor, ground floor. Definitely amount of water will be different. Parallel connection, current flows in a different volume. That is I1 is equal to V by R1 or psi by R1. No problem. Psi by R1. What is psi? 19 by R1 is 2. 9.5 ampere. I2 psi by R2, that is psi value is 20. 20 by 2, 10 ampere. 20 by 4, 5 ampere. I3 psi by R3, 20 by 5, 4 ampere. So 5 plus 4 plus 10, 19 ampere. Total current itself is 19. Individual current, if we add also, they are getting 19. That means what? Internal resistance is negligible or 0. Okay. So this is the fourth problem. Fifth problem. At room temperature 27 degrees Celsius, the resistance of a heating element is 100 ohms. What is the temperature of the element if the resistance is found to be 117 ohm? Given that temperature of resistance is 1.7 into 10 power minus 4 per degree Celsius. R1, R2, T1 is given. Alpha is given. R1, R2, T1, alpha. R1 is 100 ohms. This is 117 ohms. T1, 27 degrees Celsius. Alpha value 1.7 into 10 power minus 4 per degree Celsius. Alpha is equal to formula R2 minus R1 by R1 into T2 minus T1. Question is T2 you have to calculate. First you calculate T2 minus T1. R2 minus R1 by R1 alpha. 117 minus 100 divided by 100 into alpha is 1.7 into 10 power minus 4. 17 by, this is 10, if you put here it will become 17 into 10 power minus 3, that is 10 power 3, 1000. Therefore, T2 is equal to T1 plus 1000. What is T1 given? 27 degrees Celsius. So it should be 27 plus 1000, 1027 degrees Celsius. Temperature coefficient of resistance, basic formula. As temperature increases, resistance also increases. Okay, fine. In the case of a metal, sixth problem. A negligibly small current is passed through a wire of length 15 meter and uniform cross section 6 into 10 power minus 7 meter square, and its resistance is measured to be 5 ohms. What is the resistivity of the material at the temperature of the experiment? Resistivity rho is equal to RA by L. The data's resistance 5 ohms, cross sectional area 6 into 10 power minus 7 by length of the wire 15 meters. 15, 5 6 are 30, 30 and 15 mean 2 times 2 into 10 power minus 7 ohm meter. Ohm meter is a unit of resistivity. Okay. Seventh problem. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius, resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of silver. One is 2.1, another is 2.7. One temperature is 27.5, another temperature is 100. So the formula alpha is equal to R2 minus R1 by R1 into T2 minus T1. R2, two different resistors, 2.7, 2.1 by 2.1 into T2 minus T1, 100 degree, 27.5 degree, 100 minus 27.5. This is 0.6 by 2.1, 72.5 degrees Celsius. Calculate the value of alpha, 0.00394 per degree Celsius. 0.00394 per degree Celsius. Eighth problem, a heating element using nichrome connected to 230 volt supply draws an initial current of 3.2 ampere, which settles after a few seconds to a steady state of 2.8 ampere. Previously 3.2, now it is 2.8. What is the steady temperature of the heating element? Room temperature 27 degrees Celsius. Alpha value 1.7 10 power minus 4. You have to calculate T2. Alpha is equal to R2 minus R1 by R1 into T2 minus T1. R1 and R2 you have to calculate. V by I1, V by I2. What is the value? 230 volts, 3.2. 230 by 3.2. 230 by 3.2.7. No, 2.8. 2.8 ampere second case. First one answer 71.8. 82.1. 71.8 ampere. 82.1. It's not ampere, it is ohms. 82.1 ohms. Therefore, alpha also given 1.7 10 power minus 4 is equal to R2 minus R1. 82.1 minus 71.8 by 71.8 into T2, we have to calculate minus T1. What is the T1 given? 27 degrees Celsius. So T2 minus 27 is equal to, subtract these two, 82.10, 71.80. 3, 0, 1. 10.3 by 1.7 10 power minus 4 into 71.8. No option, we have to do simplification. So after finishing the simplification, we got the answer 867. C2 will be 867.3 ohms. 3 per degree Celsius. Second, temperature only asked. So degree Celsius. Correct, ma'am? Some calculations will be tougher. So keep logarithm book always with you to do the calculation. Manual calculation is okay, but this is all, it will take very long time. So logarithm means 2 minutes you can finish. Problem number 9. Determine the current in each branch of the network as shown. 10, 5, 5, 10. Like Wheatstone's network. 10, 5, 5, 10. Five ohms, 10 ohms. Current comes here, leaves out. This is I1. This is I2. Here, the junction A, B, C, D. I1, I2, I3. So I1, I3 means remaining current only will flow through. I1 minus I3 current will go there. Next, I3 current is coming, I2 current is also coming here. So I2 plus I3, this side. So we have to apply Kirchhoff's second law for the loop ABDA. Algebraic sum of the product of current and resistance taken around any closed network is equal to algebraic sum of the EMF. This is the question. This is the second law. So ABDA means 10I1 here, I3 plus 5I3. B to A you need, but current is coming in the opposite direction. Minus 5I2 is equal to 0. Next, for the loop BCDB, BCDB, 5 into I1 minus I3 minus 10 into I2 plus I3 is equal to algebraic sum of the EMF. No EMF, so 0. A, B, C, D, A. That full path also you can consider for the loop. A, B, C, D, A. Ten I1 plus 5 into I1 minus I3 . 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 5 into I1 minus I3 minus 10 into I2 plus I3 minus 5I2 is equal to this is 10 volts. Simplify equation 1, equation 2, equation. Calculate any two simultaneous equations and solve. With third, you compare. If it is okay, means leave it. Still, if it wrong, means use the calculator and recheck. 100% book problem, book answer cannot vary. In this case, you substitute after calculating simultaneous equation, solve. I1 is 4 by 17, 6 by 17 I2, I3 is minus 2 by 17. Okay. I1, I2, I3 we have calculated. Current through AB, that is I1, current through AB is I1. Current through BC is I1 minus I3. Current through AD means I2. DC means I2 plus I3. So in that case, depending upon the branch, whether A to B or B to C or B to D or complete, depending upon that, you substitute the value and then calculate. Okay, ma? Very, very excellent problem based on Wheatstone network. 10th problem. In a potentiometer arrangement, a cell of EMF 1.25 volts gives a balancing point at 35 centimeter length of the wire. If the cell replaced by another cell and the balancing point shifts to 63 centimeter, what is the EMF of the second cell? Comparison of EMF in the case of potentiometer. Psi1 by Psi2 is equal to L1 by L2. EMF is directly proportional to balancing length. That is the principle of potentiometer. Here Psi2 is asked. First Psi1 value 1.25 volts by Psi2 is equal to L1 35. This is 63. 35 into 10 power minus 3. 63 into 10 power minus 2. So Psi2 is equal to 1.25 into 63 by 35. Simplify. You are getting the answer. 2.25 volts. See, balancing length 1.25 means 35 centimeter. Now we got 2.25. So balancing length here is 63. EMF and balancing length both are directly proportional. That is the principle of potentiometer. Question number 11. Number density of free electron in a copper conductor is 8.5 into 10 power 28 per meter cube. How long does an electron take to drift from one end of the wire, 3 meter long, to its other end? Area given, current is given. You have to calculate drift velocity. Using that, calculate the time. Because drift velocity is not given. Formula I is equal to NEA VD. VD is I by NEA. What is the current? 3 ampere divided by number density 8.5 10 power 28. Charge 1.6 10 power minus 19 into area of cross section 2 into 10 power minus 6. Simplify, calculate drift velocity 1.1 into 10 power minus 4. Velocity, so meter per second. Therefore, question is what? How long does an electron take to drift from one end to other end? Time is equal to distance by velocity. What is the distance or length of the wire? 3 meters by 1.1 10 power minus 4. 3 into 10 power 4 by 1.1. Simply calculate the value 283.13 seconds. 283.13. No, answer is 2.73 into 10 power 4. 2.73 into 10 power 4 seconds. 3600 second means 1 hour. So you can convert that in terms of hours if you need. Otherwise, you can leave it as it is, no problem. In case unit, SI unit is only expressed in seconds only. In terms of hours means 3600 second is 1 hour. 60 minutes, 60 into 60. 12th problem. Two wires of same material have length L and 2L, cross-sectional area 4A and A respectively. Calculate the ratio of specific resistance. Length is L and 2L, area 4A and A. You have to calculate ratio of specific resistance. Rho is equal to RA by L. Same material. Whatever change in length, whatever change in area, same material means specific resistance or resistivity will not change. So rho 1 and rho 2 are equal. Same material, one word is given. So normally, but given data, they will simply do the problem. But here it is not like that. 13th problem. A wire has a resistance of 12 ohms. It is bent in the form of a circle. The effective resistance between the 2 points on any diameter. Any diameter you have to calculate. Bent in the form of a circle. Each resistance is 6 ohms. So R1, R2, total 12 ohms. So this is 6 ohms each. So I can write 1 by Rp is equal to 1 by R1 plus 1 by R2. That is 1 by Rp is equal to 1 by 6 plus 1 by 6. 2 by 6 that is 1 by 3. Rp is equal to 3 ohms. So resultant resistance on any diameter is 3 ohms. Okay, next one. 14th problem. If you are provided with 3 resistors, 2 ohm, 3 ohm and 6 ohms, how will you connect them so as to obtain the equivalent resistance of 4 ohm? 3 resistors, 2 ohm, 3 ohm and 6 ohm. We have to get equivalent resistance as 4 ohms. Excellent problem it is. Two ohms, 3 ohms and 6 ohms. Probability only 3 resistors given. The resultant resistance is 4 ohms. What are the combination you have to calculate? 3 ohms, 6 ohms, 2 ohms. 3, 6, 2. Only by probability we have to find out because 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Rs is equal to R1 plus R2 plus R3. This combination you know. So based on that we have to put the probability. So 3 ohms and 6 ohms connected in parallel. 1 by Rp is equal to 1 by 3 plus 1 by 6. 6 LCM 2 plus 1. 3 by 6. So Rp is equal to 6 by 3, that is 2 ohms. This one with another 2 ohms because question is resultant is 4 ohms. So this is 2 ohms, another 2 ohm connected in series. Rs will be Rp plus 2, that is 2 plus 2, 4 ohms. Correct, Amma? So by probability only we have to calculate. 15. Calculate the current drawn from the battery as shown in the circuit below. So this is the problem given. 2 ohms, 15th problem. This is circuit given. 2 ohms, 6 ohms, 8 ohms, 0.5 ohm, 15 volts. There 7, 1, 10. 7 ohm, 1 ohm, 10. These three are in series. 7, 1, 10. Rs is equal to 7 plus 1 plus 10. 18 ohms. This 18 ohm and 6 ohm are in parallel. 1 by Rp is equal to 1 by Rs plus 1 by Rs dash. R1, R2, R3, R4, R5, R6. This is R7. So these are the data. 1 by RS plus 1 by R3. 1 by RP is equal to 1 by RS, 1 by 18 plus 1 by R3, 6. 1 plus 2 or 1 plus 3, 4 by 18. RT is equal to 18 by 4.5 ohms. 4.5 ohms. These two, 4.5 and 8, all are in series now. So we can write RS dash 2 plus 4.5 plus 8, 14.5 ohms. 14.5 ohms. So total resistance in the entire circuit we have calculated as 14.5 ohms. What to be calculated here? You have to calculate the current drawn from the battery. So here 1.5 is also there. Here 1.5. So totally 15 ohms. Total resistance is 15 ohms. Question is, what is the current? Therefore, I is equal to V by RS dash 15 by 50, 1 ampere. 1 ampere current. Okay. Next, 16th problem. The heat produced by a 100-watt heater in 2 minutes is equal to dash joules. H is equal to power into time. Straight problem. Power into time. Power is rate of doing work. Work done is nothing but energy. So energy is equal to power into time. What is the power given here? 100 watts. 2 minutes. Minutes should be converted into seconds. So 120 into 100. 12 into 10 power 3 joules. So these are the problems related with current electricity. Basic formulas: resistors connected in series, resistors connected in parallel, temperature coefficient of resistance, Kirchhoff's first law and second law, meter bridge and potentiometer, temperature coefficient of resistance, alpha calculation. All these things we have seen many examples. Okay. Thank you. We'll continue.